Good morning and welcome. We're very grateful that you've chosen to spend part of your day with us for AI that works where it matters, the NewEra AI Family. We're excited to have you here to focus on the tools and technology that help keep our ZOS environments running and strong. Before we kick things off, I want to go over a couple quick things so that everyone knows what to expect today. This session is being recorded. You will receive an email in the next few days with an opportunity to receive a link to that recording so that you can rewatch it, share it with your team, or revisit any sections that may have stood out to you. As we move through today's presentation, you can use the Q&A panel anytime to drop your questions in. We will be going back to that at the end of the presentation to answer those questions. I want to take a quick second as well to touch on something that's been coming up more and more in conversations lately, because at this point, some of you might think it's all interesting, but what actually is going to land with the C-suite? Is AI something that leadership is going to get behind? And it's a fair question because while technical teams that do tend to get excited about what AI can do, the executives are usually looking at it from a different angle. They think about the risk, not only because they don't see, not because they don't see the value, they definitely do, but they also see um, more of a risk to it. They know that it is something that is important and is coming in the future. They hear the buzz, they know it'll play a role, but they're also asking some other questions like, is it predictable? Is it governed? Is it compliant? And can we see how it's making its decisions? Well, a ZOS environment where stability and accountability matter so much, those questions can carry a lot of weight. So that's exactly why we've taken a different approach. We're not building open-ended black box AI that makes guesses or runs off. We build a disciplined operational intelligence. Our AI works from real system data. It applies fact-based transparent logic, and everything it supports can be traced, understood, and audited. There are clear boundaries, defined scope, and full visibility into how outcomes are reached. So instead of introducing uncertainty, it'll reduce it. That's what makes this conversation resonate, not just with systems programmers, but with leadership as well. Because when AI is disciplined, fact-based, and auditable, it stops feeling like a risk and starts becoming a trusted operational advantage. And that's the foundation for everything we're going to be talking about today. Paul, can you take us a little deeper into how this works and what it means in a real environment?
Sure, Sammy. Just to sum up your introduction, this is all about trust. At the end of the day, AI is only as good as your processes that give you an understanding that what it is doing can not only be trusted, but it's something smart, something that's going to help you in your job and help to improve the overall productivity and efficiency of you and your job, and obviously the integrity of the ZOS environment. So as Sammy mentioned, what we build are often referred to as rule-based retrievers. And let me dig into that just a little bit. The rules are essentially the rules of just about anything that you can think of in ZOS, the IPL path, RACF, all of the components of the uh, communication server, like Paget, for example, or the profile deck, or any of those sort of baseline components that not only help us to bring them up and make them functional, but quite often give us the ability to protect them from bad guys who are out there trying to get in. Uh, RACD cert is a good example of that. All of these rules are been developed over time and apply not only to any given release, but apply to all the releases going back all the way to ZOS 2.1. And the training that goes into that is something that is done by our data scientists, people who understand ZOS, understand the rule-based methods that we use, which are essentially if-then decision processes. The retrieval part of it is the ability to understand the running ZOS system and the subsystems that make up that system. the ability to be able to extract information from them on demand, and then process the extracted information against those rule sets in order to make a determination, because this is deterministic AI, about the condition of that particular component of ZOS at that particular moment. So the information that's being processed is your information, extracted in real time to give you an understanding of where you are at this very moment as that extracted information is applied and evaluated against the rule sets that are part of our environment. Now, these AIs really are agents. They are operating under your command. They can be operated directly from the command line, as I'll show you, but they can also be operated autonomously. They can be set up to essentially monitor the environment without additional instructions from you, capturing changes that are going on to PalmLab members or into RACF or into the communication server or whatever the case may be, capturing them, recording them into what we refer to as a repository. That repository essentially gives you the ability to query it at any point in time to create compliance reports, audit reports, or under your guidance, can be used as the basis for alerts. That is, if something changes that's of particular interest to you, then an alert could be sent to you directly by email or routed to, for example, ServiceNow. The agents run on-prem, so there's never any concern about data leaking out, if you would, because it is in the public domain in some way. So it's totally under your control and the control of your security group to manage that data in whatever way you see fit. So today we have three such agents, one for the control editor, one for validated boot, and one for image focus. They are referred to as AIs, TCE AI, Val Boot AI, and IPL Check AI. Their focus is to support your workflow. As a systems programmer, we see the summary of what you do as always making a backup before you make a change. So we want to put in place a viable backup for all of the components that you are responsible for, to give you a baseline for configuration management and to control access to those components as deeply as you want to go, even to the point of um, um, the highest levels of control that we can create. We want to help you as you move forward to put in place a clean room to be able to build the key rings and the certificates that will be necessary to enable secure boot when you attempt to do that in the future. And of course, we want to be able to monitor the IPL path to make sure that it's viable and report to you not only the findings that come from image focus, but the exceptions that come from the IBM Health Checker for ZOS and the dynamic changes that occur when we measure or monitor the difference between the configurations that are used to start the system at IPL and the way in which memory is configured at any given moment in time. Remember, most of these tools are real-time, operating on real-time data, and providing you with a true understanding of not only what has been done, but what is being done and what might possibly need to be done in the future to ensure the integrity of your ZOS environment. So what we're going to do now is we're going to go through some use cases. Sammy's going to introduce you to them, and then I'm going to take you through a more detailed explanation of each of them. So Sammy, how about the first one?
Absolutely. So we're talking, as Paul said, about some real world scenarios you might start hearing from, especially from the C-suite. A lot of the time, these needs don't just appear out of nowhere. They'll come from something like an audit finding or a consultant report to the board that starts highlighting things like compliance gaps, auditability, and avoiding penalties. That's usually what's going to get the attention. One of the most basic but critical use cases that comes out of this is real-time recovery. And why does it matter? Because having a reliable recovery point takes a lot of fear out of the equation. If something fails, whether it's a component issue or a bad change, you're not going to scramble. You've got a clear path back. At the same time, there's another challenge happening in parallel, which is access control. You want the right people to have access that is needed to manage the systems, but not more than what they should have access to. So over permissioning is always lurking in the background. So how do we handle both these things without making everything more complicated? Well, that's where the rule-based categorical controls come in. And don't let the name make it sound heavier than it is. Think of it like this. You define categories however you want and group things together that matter to you. That could be data sets, Unix files, operator commands, system messages, whatever's relevant to you. From there, as the activity happens, everything gets tracked and logged based on those categories. So instead of chasing individual pieces, you can look at things in a way that actually makes sense. You can pull that data however you need by, again, the data sets, by a file, by a category, and you can see exactly what's changed, who accessed what, and whether that access was expected or not. And the payoff is that you can spot issues quickly. When something does go wrong, you can simply roll back to a good known state, whether that's fixing a simple edit mistake that didn't show up until a restart or addressing something bigger. Then on top of that, you've got a clean, clear way to demonstrate compliance when auditors do come knocking. Even better, it all runs proactively. You can set it up to notify you when things change or when new events occur completely on your own terms. And at the end of the day, you're in control. So whether you're thinking like a data scientist, a decision maker, or an operator, you're guiding how AI behaves and what it watches for. So Paul, can you go ahead and show us how this actually works?
Sure. So let's talk about roles here. So our role is to engage our data scientists in the creation of the rule sets and the models themselves that will apply the if-and logic that I mentioned earlier. Your role is as a decision scientist. A decision scientist essentially plays in this game by deciding whether or not what the models are doing is something smart. Does it make sense? Do you understand it? Is it adding value in your organization? And that's the role that you play. Because at the end of the day, as Sammy is going to continuously mention, the C-suite is concerned about the trustability of these and whether or not they actually will reduce the load on you, contribute to long-term profitability and operational integrity. And the only person that can answer that question is you. And the main target is, did it do something smart? So in the case of the control editor, or what we refer to as TCE as Sammy mentioned, there are five basic areas that we are focused on. We come with a pre-canned set of rules that revolves around data sets, libraries, HFS files, commands, and messages. And within that context, here's just one example of what you get right out of the box. When you install this, the first thing that it will do is it will make a complete backup of parmlib and proclib to ensure that you have that backup and that it's verifiable. And that as we go forward in time, any changes that occur to those files that are in that backup will be recorded in the event journal so that you're always assured that in real time, you will always have a recovery position in order to fall back to should the case be necessary to do so. This can be taken to a number of different levels across all five of these. The most important from a data set perspective and an access perspective is being able to take it to zero trust, to be able to implement on top of the access controls that you already have, additional controls that can address the problem of over-permitting individuals without having to actually make changes to RACF or ACF2 or top secret, consistently reducing the load on you to be able to implement zero trust and to attack the issue of over-permitting. In addition, real-time notifications can come from this system as well. Some of them are pre-programmed in, some of them you will design and develop yourself. The difference is that we will give you some defaults, but you will have access to what we refer to as weights in order to be able to change those defaults to fit the needs of your specific organization. Everything is recorded in a control journal, every action, every event, and those can be used in turn for restoration, for auditing, and for history of one kind or another. The history typically being used for compliance reporting. So, Sammy, let's move on to the next one.
Absolutely. So another thing that's going to start bubbling up from the C-suite over time is control, specifically improving the control processes. And this isn't happening in a vacuum. It's really being driven by how fast ZOS is evolving. Updates are coming quicker, changes are rolling out faster, and as DevOps continues to make its way into the ZOS world, that pace isn't slowing down anytime soon. So now you've got a different team. You have a lot of different teams touching pieces of the system, receiving different components, modifying them, passing them along. But here's the shift. You're no longer just managing a system, you're a part of the supply chain. And that is a big thing because what you're doing directly impacts what ultimately gets delivered to the HMC and installed. So naturally, the expectation becomes how do you prove that what you're sending forward is trusted? Well, that's where the idea of a clean room comes in. Think of it as a controlled environment where you can confidently say, I built this, I signed this is valid, and it's safe to use in the boot process. That boot process, by the way, is what we are often calling secure boot. And the work that you're doing here is part of enabling validated boot. So um, I know it can get pretty complex with all of this. You're dealing with things like key rings, permissions, certificate creation, relationships with ICSF and PKDS, and actually signing modules and system volumes as they move through the pipeline, and it's a lot. And honestly, this is where something like Valboot AI becomes incredibly valuable because keeping track of all the fingerprints, the subject key IDs, and everything that's required to validate these components over time, it's not something you want to have to manage manually. This is about making sure everything that goes into your system is trusted, traceable, and ready for a secure boot. So, Paul, can you show us more about this?
Sure, just one overarching point here. While Val Boot will help you set all this up, I want to make it clear that Image Focus will actually track the secure boot process. So if it detects that you are attempting a secure boot or you have secure boot set up, then it will monitor that process itself and determine whether or not you would either reach a wait state or a warning when you attempted to use those components to actually perform a secure boot. So this goes beyond the AI into the world of image focus, and it is clearly a set of tools that can help you to manage this more complex process. So how does this work? Well, first of all, the the data scientist who actually described the workflow that we implemented is a gentleman by the name of Kevin McKinney, who is an IBMer, who is responsible for the documentation of the validated boot process. He wrote it into a white paper. If you would like to get a copy of it, I'm sure we could provide you with one. Just send an email to either Sammy or technical support, and we'll get you a copy or a link to it. But what we did was we took that description and we coded it as a set of rules, and we encoded it into what we refer to as Valboot AI. So we are actually not integrating directly with some process in ZOS. We're actually implementing the thoughts of someone who actually described in great detail how this process is supposed to work. But the truth is that at the end of the day, our work has to be evaluated by you. You are the decision scientist. And so when we are done, you're the one who will have to tell us, did we do something smart? Did we do something that's helping you to improve the efficiency, security, and productivity in your environment? Those rules are encoded in such a way as to give you access to the structures and workflow that's necessary to build key rings and certificates, interface with ICSF, and build the necessary profiles and permits, and then assemble them in order to create an environment of components that can be used for signing the specific components, load modules, and sysres volumes in order to be able to actually send componentry to those teammates at the HMC to be used in a secure boot. So that export process of the signing certificate becomes a critical link between your work in validated boot and their work in secure boot. Throughout the whole process, we have additional components that will monitor to make sure that the certificates remain valid and provide processes that will allow you to easily renew them if it becomes necessary to do so. So, Sammy, let's go on to the next one.
Absolutely. Thank you. Um, so this one's pretty straightforward and pretty inevitable from the C-suite. So basically, this is, can we stop IPL failures caused by ParmLib errors? Because at the end of the day, those failures are painful. It's not just frustrating for you as a person managing the system, but it's also a big deal for service providers. They and those who are offering IPL as a service. So up to a point, the risk and cost of the failure is kind of baked into SLAs. Everyone knows that things can go wrong, but there is a tipping point. As the recovery drags out, the cost starts climbing and fast, and not just in terms of fixing the issue, but in what that downtime actually impacts. If a production system can't come online, then a lot of things can happen. HR processes are delayed, transactions aren't happening, business operations start stacking up behind the outage. And that's really where it hurts because now you're not just dealing with the recovery costs, but you're dealing with the loss of revenue, any missed activity, and it kind of ripples across the business. So, again, from the C-suite perspective, it becomes a very simple ask of how do we prevent this from happening in the first place? Is there anything you want to add to that, Paul?
I think the major point might be to take away this can be applicable to individual organizations who have uh, a range of different sizes in terms of the number of LPARs that are being managed. But when you step back a bit and you begin to look at people that offer services of running other people's environments as a service, this becomes absolutely critical because the service level agreements in those environments are costly. They have bites in them that say, if you can't hit it here, it starts to cost you money. And as it does start to cost money, those service providers really run into a problem. So this has applicability not only on-prem for those organizations that have that need, but also for service providers who may be managing any number of different uh, hardware environments, not only their own, but also the individual ones that they have contracted with. So yes, this is all about money. This is all about profitability. This is all about the one thing that the C-suite clearly will understand, that if that IPL doesn't take place, then costs are going to be incurred. And so tools that can help you to manage that become critically important. Let's talk a little bit about that. Again, the role here as decision scientists is to make certain that we do something smart, something that will help you, something that will ensure that those costs are not incurred. And in order to do that, we're going to build our AI, IPL Check AI, on the proven technology of the Image Focus platform. And that platform has been extended to operate entirely under the control of the IBM Health Checker for z/OS. Now, why did we do that? We did it because image focus is capable of inspection. Inspection is a process of evaluating the IPL path to completion and then its subsystems to completion to report errors, warnings, notices, and information. Also, in the case of running under the health checker in a given LPAR, detecting dynamic changes in system symbols, APF lists, VPX lists, all the others as well. But added, because of the integration into the health checker, is our ability to understand its results as well. We refer to those as exceptions, and they are reported as high, medium, and low. When you combine all of that together, along with the ability to track changes along the IPL path, and what you have is a gestalt that paints a picture for you, not only of the integrity, but the stability of the platform itself, of the IPL path end to end, as viewed by the major tools, image focus and the health checker, operating with each other together. Now, as is the case with the other AIs, we ship this with a number of defaults. There are things that we think are errors, warnings, whatever, and you may not feel that way. And so the weights allow you to change the weighting so that the severity and the outcomes that are reported are based on what you want and not necessarily on what we want. And in those cases where there may be some mismatch of understanding, we're standing ready to help you to adjust those weights to make sure that you get from this what you want. In addition, this AI comes with an integrated development environment, which gives you the ability to explore the data analytically and gain insights from what it has been capable of doing, and also to send any number of reports, alerts, notices via email, by FTP, or by services like ServiceNow, using the web enablement toolkit for other services should you have other specific needs. So at the end of the day, Sammy, we really have three, and here's what their interfaces look like. TCE, val boot, and IPL check. Again, TCE is all about verifiable backups. Val boot is all about the clean room, and IPL check is all about monitoring the IPL path end to end. The goal is to support the system programmer's workflow, to have him demonstrate as a decision scientist whether we do or don't do something smart and to work that out with us, and to prove to the C-suite that these tools can be trusted to improve the overall productivity, efficiency, and reliability of the IBM ZOS environment. So let's take a quick look at what these look like interactively in a demonstration. So unless there's some questions as I segue, I'll start a demonstration. Let me know if you have any questions, Hannah.
No, all the questions in the chat have been answered by now and deleted from there, so you can go
Okay.
right ahead with that demo.
All right. Thank you. All right. Well, obviously, I'm excited about this, so don't be alarmed if I get overly excited. So the one thing to take away, something that many of you may sort of have some concern about, because much of image focus and the control editor interactively run in a VTAM application that we refer to sometimes as the ICE environment or IFOM. But these all run from the TSO command line. So it's just as simple as going to the command line and typing, for example, TSO $command line interface, comma, and now we have to put an asterisk here and CE IDE. So Control Editor Integrated Development Environment. Now these are all TSO commands, and so they could be strung together. They could be incorporated into other menus that you have that you use in your daily work. They're very flexible and they produce significant improvements in the exploration of the data that is produced by, in this case, the control editor. So here's the basic interface that TCE AI offers you. Let me get some of this Zoom stuff out of the way. You can see the 5 different categories that are areas of interest here. Data sets, load libraries, USS files, commands, and messages. And each one of these, of course, is able to afford you the ability to group certain elements of them into categories that make sense to you and what it is you're trying to do. As I mentioned, if we look at just data sets here, just for example, this is a local development system that I operate on, so it's not particularly overweighted at this point. But you can see up at the very top, there is a category called System Parmlab. And that category wasn't one that I created. It was one that the system created automatically when the control editor was first installed. And so if I put the cursor under System Parmlab and press Enter, it'll show me the list of data sets that it found and grouped together at the time of the installation to ensure that I would always have a consistent backup available to restore if necessary in the case of whatever problem might exist. If I put the cursor under System Parmlab and press Enter, it'll show me all the data sets that are in that particular data set, or excuse me, all the members that are in that particular data set within that particular category. And it'll also show me how many versions of that particular member are in the control journal now at this particular point in time. So from the beginning of time, from the beginning of when this was originally set up, there have been 5 changes to ADYSET00. If I want to see what those are, I can list them out. So here they are. And I made one change earlier during the week. Now, what's interesting about making changes once the control editor takes control of a particular data set in a particular category is this. If I decide that I want to edit this, and I can do that either from 3.4 or some other mechanism, or I can do it from here, and I add a line, if I just insert something, let's do some nonsense here, just those M's, and I press enter. Now you're going to see something very unique. This is what we refer to as a descriptor panel. And here's one of the ways in which you can control through changing the weights in the way in which the system performs. These panels are shipped by default, but you can customize them and groom them to fit the requirements of your organization, even integrate them into other parts of your system if you choose to do so. Here, what's required is that I complete a certain amount of information, which you can decide on how complete you want this form filled out, and require, in some cases, uh, detailed change information. This is for a demo. And when I P-up3, I get another panel that asks me to confirm whether or not I want to commit this change and the descriptive information to the control journal. If I say yes, then the member will be updated and changed according to the way in which I did it, assuming I have the appropriate authority to do it. And that information, along with the member and the description, will be recorded in the control journal itself. So if I hit Y and press enter, now I'm back to where I was originally. If I P-up3 out of this and I come back in, we'll now see that I have 6 changes. So I had 5, now I have 6. If I list them out, Now here's the one that I just changed. Shows me the version, how many records, what kind of event, who did it, what was the date, the time, and what was the data set that it was in. And if I want to actually see what's in there, then I can actually see what that change was. So this is for a demo. This is who did it. You can see that information up here. This is the actual change that got recorded. So either one of several things might happen now. This has been recorded in the control journal, but there could have been additional descriptive information in the configuration that you define to the control editor to actually send a notification when any change like this took place. And you would already have been notified, and this descriptive component that we're looking at now would have been sent to you. So all of these other ones essentially act the same way. You can see across the bottom there are many other weights that can be adjusted, prompts, padlocks, multi-factor authentication or editing components. This is the zero trust component of this. Whether we want email notes, whether we want notification on edit. Notification on edit is kind of an interesting thing because what it does is it says that if a change has been made that isn't known by the control editor, at the time you attempt to make that change, then it's going to actually notify you that something was made that changed a member outside of the controlled environment, perhaps from another system, as the case may be, or maybe something copied in from another system, as the case may be, and ask you to validate that change before it allows you to make a change to that member as you go forward. So very high levels of control here in your hands as the decision scientist to decide what it is you really want to do. Now, moving on here, TSO, dollar, and, oops, excuse me, dollar command line interface, comma, val boot, IGE. Now remember, as I said in the presentation, this is not interacting from a rules perspective directly with some published rules about ZOS. This is actually interacting with a set of published rules by a gentleman named Kevin McKinney, who is the author of the processes that are necessary to establish a validated boot environment. So if we here for the first time just said, okay, I see this, but I want a key ring, but I don't know anything about how to set that key ring up, I could just go to this down here and say, create, update, and profile a key ring. And it would do that for me. And so here's the key ring setup that's necessary in order to build a key ring where you are the owner, that here's the key ring name, here's the R data log profile that's necessary in order to create the necessary profile and permit it for access during assigning. Here's the facility class profile name. By default, this must be the name. Here is the APPL data component of that facility class profile that's so critical during the signing process. I will be permitted by default. We're ready to go. But let's make this a little more specific. Actually, what I think you will want to do when you set up your key rings is you will want to make them accessible by specific users. And so you can assign a specific user to a key ring and maintain that integrity of that key ring just for that single user. Let's look at all the key rings that are set up. So we have one here that is the one I like to test with that was set up some time ago, has some certificates attached to it. Let's go ahead and delete it and we'll rebuild it. So, like all the actions that are taken by this particular AI, everything is traced and documented and shown in a trace that shows us what actions it took, what replies it got, and any failures that may have occurred in the process itself. Exactly what you would see if you were doing this from the command line, accessing RACF directly to, or RACD cert directly to build that particular key ring. Let's go to certificates, because we want to get rid of those too. So we'll get rid of this one. And we'll get rid of this one. Okay, so now we're good to go. So now we'll start over again. Arobi 1, build me a certificate, or build me a key ring. So now we have a key ring that has Arobi 1 appended to it. And that's critically important, because what that means is that even though I am the owner of the key ring, the only person who can actually engage with this specific key ring is someone who will act as a signer who's signing, excuse me, whose TSO user ID is Arobi1. You can see we built the RDataLive class profile. I'm permitted automatically, but Arobi1 has now been permitted as well. So we'll check that. If we want to do it, we can see the facility class profile name has my name on it. You can see the APPL data. These are all requirements. We can see that Arobi1 has been permitted or will be permitted. Press enter, and the commands have been issued. And when we hit PF3, we can see that the key ring has been added, and there are no certificates yet to be used in this particular key ring. If we back up, and now we say we'd like to go ahead and add some certificates, now in this particular instance, when you're setting up a clean room, the val boot process requires that the signing certificate be signed with a cert auth certificate. And so you have to build two certificates in order to make this go. Let's assign a common name of NewEra. Let's assign an organization name of development. Oops. You'll notice that there is also information that's been assigned here by default, but a requirement that the name here for the signing authority certificate be VBCERTAUGH, and for the signing certificate, VB signing. So those are requirements, and the reason for that is that if this certificate or any of these certificates were to expire and we were to rebuild them, we would need this information about the cert auth certificate in order to re-sign the signing certificate. A bit of a complication, but this interface takes care of that problem for you. Now we can build the certificates. Notice our key ring is shown at the top, so this is what we're going to attach to. This is the RACD cert command to build the cert auth certificate. This is the RACD cert command to build or generate the signing certificate, the ID certificate as it's sometimes referred to. And all of this information that's in the command itself is as described in Kevin's white paper. So the certificate size for the for the Cert Auth certificate is 496, and it's a RSA certificate with its private key stored in the PKGF. The signing certificate is a NIST elliptical curve certificate, and its key is also in the PKDS, and its size is 512. So we need all of this. This will all be done in sequence. So I think by now you're probably getting the idea. So this is a workflow. This is the path that I need to be on in order to describe a few things that are appropriate to my organization in order to build all of these constructs in order to create the necessary components. And here we have them. So now we not only have the keyring, we also have the certificates there themselves. Now let me move on here. It's not just enough to build them. We also have to be able to test them and maintain them over time. Here's some that have been pre-built. This is a volume. We're testing to see if this volume is still signed and if its signing is accurate or correct. And right now what it's saying is that it cannot match the subject key ID. And that's because it isn't signed with the current set of certificates that are attached to that keyring. Because remember, I deleted those certificates, so I'd have to re-sign it. So it can give us some information about what it is that it's signed with, but it's telling us that it won't work now because it's not signed with the appropriate certificate. So not only can you build things, but you can sign things and you can test things over time and you can monitor them as well. So let's go on. Now this is IPL Check AI. Now, IPL Check AI has many different implementation possibilities. The one that you're looking at now is what we refer to as an ensemble. An ensemble is a collection of inspection traces, we call them logs sometimes, that have been aggregated into a common repository that this particular instance of IPL Check AI has access to. One of those logs is being created by the running system. That's the one here in green. One has been created that we refer to as the goal system so that you can use the goal system to actually monitor for drift across all the other systems if you choose to do that. You can compare one environment against another just by checking that and saying compare. And this guy will compare the errors, warnings, and notices of the goal system against the target system, in this case SOW1. And it will tell us if there are any differences. And then if there are, then we can place the cursor under the difference and it'll show us exactly what it's finding and telling us that's different. And also do the same thing for, uh, excuse me, items that come from dynamic changes. In this case, the differences between the goal system and the uh, system, the target SOW1, the same is one, that is, there is one thing that is the same, and then there are six things that are different, and we can see exactly what those six things are. So a good way to keep track of multiple different systems across not only changes in the system itself, but also against a gold standard, if you would. Putting the cursor under the local system, lets us drill down into additional information about what's in the log. If we were looking at this under the classical way, under 3.4, it would look like this. These logs are, in this case, this one happens to be 18,234 records long. But much, if not all of that information is summarized here in this panel. For example, the current findings. Well, we have 13 notices. What are they? Here they are, broken down by message types. So you can see the messages are grouped together, not only by message type, but also by location in the log. We can see health check types, medium health checks. You can see the date when the last run was, or this is the current run, 326. This was the prior run, 207, and everything seems to be essentially the same. We can get more detail if we want to. A number of different reports are available here. These are prompts to the underlying logic to produce the IBM program property table. Usually comes in a coded form. This is in the form of a module called IEF SDPPT, but here we've decoded it. So if you have never seen the content of it and what it really relates to, this is a good place to come and take a look. Auditors may ask you for this at some point. Backing up, you can do the same thing with any of these others as well. So ENOX, and notice here, this one doesn't have a baseline. It indicates that in red, and we could create one by just cursoring under create and pressing enter. And it doesn't have verifiable backup. So that essentially means that it's not running the control editor at this particular point in time on that particular system. So that might turn out to be an issue worth paying some attention to. Exceptions. These come from the IBM Health Checker. In an ensemble, it's quite likely that we'll have access only to the current running system. If we were in a sysplex, however, we would have access to all the systems, and so we could see the results of the IBM Health Checker across all systems in the case of the sysplex. So I'm just backing up. Okay, so let me stop sharing this. Go back to the presentation here just for a minute. I can find my sharing button. There it is, right there, yeah. So, Sammy, what did I say? Sum it up for us.
Absolutely. What we're seeing and essentially the takeaway from this presentation is disciplined operational intelligence. It's not guesswork. This is years and years of experience and being able to develop the rule sets that are necessary in order to implement the if-then logic that's found in AIs that we're building. This is AI that differentiates itself from generative AI that the C-suite may be suspicious of. It runs on-prem, it's highly auditable, and the findings are clearly documented. And you have the ability to change the sets through the adjustments if you choose to do so. like I said, you can audit it. It's intelligence that works and is deterministic, and it's built for ZOS and designed for trust.
The This just happens to be a diagram of essentially how our data scientists actually go about the process of building the logic that's built into the server itself. So starting with just the simplest of constructs, automatically finding a data source like a unit address and load parm deals with the next step, which is a collection and normalization of that information. Then the retrieval layer actually begins to retrieve information directly from that system and begins to apply the rules that have been engaged into it. Relevant information is then extracted, analyzed by the rule-based analysis. The AI explanations and recommendations are essentially created and then reported in the form of a dashboard. As we've mentioned throughout this, we currently have three. We'd really love your feedback. We'd really love to give you a client briefing and to present you with a proof of concept. Remember, all of this is intended to support you as the decision scientist in your system programming workflow. We are going to have another introduction of an AI later in the month of April that we refer to as Certificate Intelligence AI. And Sammy will be in touch with you about that. And I hope that you'll come out and see us then at that point. Well, Sammy, wrap us up, please.
Absolutely. We just did have one question that came in asking about what a typical implementation timeline might look like. Do you mind spending a moment on that, Paul?
It's relatively simple. For those of you that are existing NewEra customers and have installed Image Focus or the control editor, know that these AIs come as part of the package that you receive from us. So once you've installed them, then it's just simply a matter of going to the command line and issuing the instruction, making sure that you have the appropriate permissions to do the work that's necessary of the AI, and you're on your way. So it's relatively easy to do, very straightforward. The major differentiation is that you can do it from the TSO command line, and they all have unique user interfaces and dashboards that are not found in the control editor or in image focus. So very simple.
Wonderful. Thank you so much, Paul. And thank you to everyone who joined us today. We really appreciate your time. As Paul has mentioned, we will be following up with an email. We would really love to get your thoughts on how the presentation went, if it went over the information you were really looking for, or if you do have any additional questions you didn't have a chance to ask today, please let us know. We would be more than happy to answer those questions for you. We can schedule a one-on-one briefing or have you check it out in your own environment with a POC. Anything you're looking to do or have questions answered, we are here for you and we would love to do that for you. One more time, thank you again and have a wonderful day.